This lesson, let's talk about sequences. So what is a sequence? It's just a set of numbers listed together. And actually we have all kinds of sequences. And one of the most famous one is a Fibonacci sequence. And let me just show it for you. So can you see the pattern here? And can you deduct what is the next number? It's one of the most famous one because the addition of the two former numbers is a third number, and 2 plus 3 is 5, and 3 plus 5 is 8, and 5 plus 8 is 13, 13 plus 8 is 21, so the next number is 34. And all the amazing sequences we are covering here have unparalleled importance in future studies, say in coordinate polar systems. Fibonacci sequence actually means a spiral line, and this is what it looks like when you're learning polar coordinate system. Let me give you another sequence. So as you can tell, 1, 2, 3, 4, 5, 6, 7. So what is the pattern of this sequence here? So you can see it's all natural numbers, and or in another word, you can just plus 1 to get the next number. And what about this? 1, 4, 7, 10, 13, 16, and what is the next number? So from this pattern, you can see you can just plus 3 to get the next number, and for the next of 16 would be 18. And let me just give you another one. So 1 minus 2 minus 5 minus 8 minus 11. So what is the next one? So you see this still plus the same number between the sequence, but they are plus -1 minus 1 to get the next number. So the number after 11 would be minus 14. So what about I give you another sequence, let's say 1, 2, 4, 8, 16, 32, and what is the next one? So you see from the pattern here, they just times 2 after each number, times 2, times 2, times 2. So the next one would be 64. And you could also multiply or times different numbers. Let me give you this one. 1/2 and 1/6 and 1/18 and 1/54. So what is the next number? And as you can see from the pattern, they just need to time 1/3, 1/3, 1/3 to get the next number. So after that, I would suppose the next number would be 162 divided by 1. And besides all of this, we also have other special sequences. For example, let me give you this one. 2, 3, 5, 7, 11, 13, 17, 18, 19. So can you guess what is the next number and what is the pattern here? Well, they do not follow a specific relationship here because you can't +1 +2 +2. There seems to be no pattern, and it can't either multiply any numbers. So what are the common patterns here? Well, if you are allergic, if you are sensitive to numbers, you'll find these are actually prime numbers. So the next one would be 23. So a prime number cannot be divided by any numbers except for 1 and itself. So these are prime number sequences. And let me give you another one. So 1, 4, 9, 16, 25, 66. And what is the next one? And as you can observe, they are 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So the next number would be 7 squared, which is 49. And these are called squared number sequences. And let me see this set. So 1, 8, 27, 64 would be the next one. So if you look at it more time clearly, it will be 1 cubed, 2 cubed, 3 cubed, and 4 cubed. So the next number would be 5 cubed. so it's 125. These are all the special sequences that we will learn, and you need to have a strong observation power. What we're mainly covering in this lesson about our two definitions. The first is sequence, and the next is series. So what is a sequence? That is a set of numbers that we listed before. Let's say 1, 3, 5, 7, 9. You basically just plus 2 after each number to get this sequence. But what is a series? The official definition is that series are addition of sequences. So if you plus those numbers above, it will combine as a series. And our question is quite clear. So if we define them as A1, A2, A3, A4, A5, how do you find the 100th term? And how do you find its sum of 100 terms? So A1 plus A2 plus A3 plus until A100. And how do you use a common expression to make its nth term, an equals 4? And that's what we're going to be covering after the later studies. Let's do a simple series. 1 plus 2, 1 plus 3 plus 4 until 100. And it's also solved by Gauss when he was 7 years old. He was a really genius. So how to do this arithmetic sequence? Well, we can't now count it one by one because we have 100 terms. If you do it by hand, so what about we give you 1,000 terms? It's almost impossible for you to do 900 more times calculations. You have to use your observation to find the rule here, to find the pattern. Well, so this is a quite interesting way for solving arithmetic sequence. What if we rewrite the sequence reversely? So it's 100 plus 99 plus 98 plus 97 plus until 1. So what can you see? What can you see if we combine them together, if we put them together? So you see 1 times 100 and 2 times 99 and 3 plus 98 and 4 plus 97, and for the last set 100 plus 1, it all equals 101. So I would say I choose one of them as a set, as a group. So how many groups do I have? Well, I have 100 numbers, and each two of them form a group. So I have 100 divided 2, I have 50 groups. So it would be 101 times 50, so it's 50-50. And that is the answer of the series. And it's a quite smart way. And later, for all the arithmetic sequences, we're going to use this. And so we can try to solve another sequence. So what is the sum of 1 plus 7 plus 5 plus until 101? So still you can write it. I'm not giving you a formula, and I'm trying to encourage you to do it by hand. So you can rewrite it inversely, 101 plus 99 plus 97 and plus until 1. So you see, they seem to follow the same pattern as before. So 1 plus 101 is a set, and 3 plus 99 and 5 plus 97 and 101 plus 1, they all equals the same number. So it will be 102 times. So how many numbers do I have? Oh, that is a tough question. Because you see, these are all odd numbers. We do not actually have 100 numbers because every number has one space. So you see, within 100, we have 50 odd numbers and plus 1, so we have 51 numbers. And each two of them combine as a group. So we have 51 times 2. And literally we have 25.5 groups of numbers. So it's 102 times 25.5, and that will be the answer of this series. So let's try to define what is officially a arithmetic sequence. given you different terms, A1, A2, A3, A4 until a nth term. So you plus each constant after every term. So this is called arithmetic sequence. And as you can see, A2 equals A1 plus D, and A3 equals A2 plus D, which is A1 plus 2D. Because you have two gaps here, 2D. And so the same can be applied as A4 equals A1 plus 3D, and A5 equals A1 plus 4D. So AN equals A1 plus, you see, 5 corresponds to 4, 4 corresponds to 3, 3 corresponds to 2. So you're plussing n minus 1 difference. So this is a general formula for finding the value of AN. And using this, let me give you a arithmetic sequence. So these numbers are like this: 1, 4, 7, 10, 13, and I want you to find its 56th term. So still, let's go with its general term. So general term, AN equals A1, so it's 1, plus n minus 1, and its common difference is 3. And so 3 times n minus 1, so it's 3n minus 2. And for its 56th term, we can just substitute value of 56 inside. So it's 3 times 56 minus 2. So it would be 168 minus 2, which is 166. So this is how we're going to find one specific term in a sequence. We find its general expression and then substitute the terms inside it to find the value. And the next question is, how are we going to find the addition of this of a arithmetic sequence? So let me give you this. So it's Sn equals A1 plus A2 plus A3 until An. And I'll give you a practical one. So Sn equals 1 plus 4 plus 7 plus 10 plus, let's say, A100. It's a 100th term. So how do I find the sum of this arithmetic sequence? As we deducted before, the nth term has a fixed relationship with A1, so it's A1 plus n minus 1 times common difference times D. And we also have the fact that when you write it conversely, A100 times A99 times A98, and times until, for the last term, 1, 4. For arithmetic sequence, their sum of the first term and the last term, the second term and the second last term, they all equal each other. So they can be combined as a group, as a fixed set. So for the formula, it would be A1 plus AN. They form a set. And how many sets do we have? We have n numbers. We have n numbers and just divide by 2, and that's how many groups we have. And what we are writing here is the formula for solving a series of arithmetic sequence. And so we can just apply them. We have deducted before that An here equals 1 plus n minus 1 times 3, which is 3n minus 2. So the formula would be A1 plus An times n times 2 divided by 2. So this is the formula for finding the arithmetic series. And we can just substitute 100 here because we have 100 terms. So as 100 equals 1 plus, oh, here is 2. I'm writing it wrong. It's 2. 1 plus 3 times 100 and minus 2 and times 100 over 2. And this is the sum of the arithmetic sequences. And so let me just help you to review the definition again. As for the arithmetic sequence, you basically plus a fixed constant after each term. So it's plus d, and plus d. And under this rule, we can find the general formula for its nth term. It's a1 plus n minus 1 times d. And its sum of sequences, the series, can be written as a1 plus an. We can consider it as a set, and times n over 2, because we have the total number of n, and each two of them combine as a group, so we divide by 2 to get the number of its groups. So this is the expressions for arithmetic sequences. And of course, if you substitute an here, and we can simplify it as a1 plus a1 plus n minus 1 times d times n over 2, and if we expand the brackets, we will get it's a1 times n plus 1/2 n times n minus 1 times d. So both of the formulas work for finding the sum of the sequences. And so this lesson is about introducing you the basic sequences and help you to find the sum of the series of arithmetic sequences and find a certain term of it. And hoping you can learn as well. And let's just get into geometric sequence next class.